Hello, everyone, and welcome to this IDF webinar in celebration of the World Food Safety Day that will be celebrated on 7th of June. My name is Aurélie Dubois. I work for the IDF head office in charge of food safety and standards for methods of analysis and sampling. I'm happy to welcome you to this webinar today. Just a few words about IDF. So IDF is a non-governmental organization that works along the dairy chain, established in 1903. We currently have 41 member countries around the world, representing 2/3 of the world meat production, and about a network of 1,200 experts contributing to the various area of work that you see on that graphic. We work a lot with intergovernmental organization, FAO, Codex, and more, and also with non-governmental organization such as ISO, ICAR, and so on. We provide guidance for the voice of the dairy sector, and we're here to support you and your colleagues along the chain. Today, we're going to have one moderator and two speakers. So our moderator today is Bruun Kastrup. He has had or currently has leading role in IDF Standing Committee, food additives and residues and chemical contaminants. He's also represented IDF at several committee meeting and ISO meeting. Is currently co-chairing an IDF action team on guidelines for the application of WOHA, the World Organization for Animal Health, Terrestrial Animal Health Code, to dairy processing and export trade in relation to foot and mouth disease virus. He has 30 years of background as a dairy technologist and 20 years experience. Sorry, it's good. As a regulatory and trade advisor in the Danish Dairy Board, with a focus on interpretation of international food safety regulation. Our first speaker will be François Bourdichon. François is the current chair of the IDF Standing Committee on Food Hygiene and the director of laboratory methods and microbiology in the cooperative Sodial in France. He holds a master's degree of general microbiology from the Pasteur Institute and a PhD from the Università Cattolica in Italy. He has 25 years of experience with the food industry, working for major dairy companies and confectioneries. Marie-Claude is the chair of the IDF Standing Committee on Dairy Science and Processing Technology. She's a research scientist and team lead at the Agriculture and Agri-Food Canada, with over 20 years of experience in the dairy sector. She specializes in dairy processing, combining expertise in dairy chemistry and microbiology to develop sustainable industry-driven solutions. Her work focuses on valorizing dairy co-products and advancing innovative technologies to improve processing and productivity. So I'm very proud today that we have such experience and only three people. So really thank you for contributing today. And now I'm going to pass the floor to our moderator, Christian, please.
Thank you very much, Aurélie, for introducing this event. And the event today is planned for these two speakers already presented. And the themes of the two presentations will be Pasteurisation as a Global Food Safety Solution, Lessons from the Past by François, and then followed by the Pasteurization, Surveillance and Alternative Technologies, Pasteurization as a Benchmark by Marie-Claude. And as already indicated, there will be room for a few questions and answers between the two presentations, and then we will take the full question and answers session in the end of today. Next slide, please. Yes. So every year, WHO, World Health Organization, is having this World Food Safety Day, and normally IDF contributes and to try to present and explain our role in our specific business. The World World Food Safety Day theme this year is From Burden to Solutions, Safe Food Everywhere. And it is about foodborne diseases may affect everyone everywhere. And understanding the extent of the burden allows national authorities and business owners to take targeted action. And especially the word targeted is very important in the dairy business, where we believe that we know better than anyone else. And we really know how to handle our specific and very sensitive products. Next slide, please. The International Dairy Federation, IDF, will celebrate the World Food Safety Day this year by focusing on the critical role of milk treatments, particularly pasteurization, including other heat treatments, in ensuring safer food and promoting public health. Today's event aligns with the objectives of FAO and WHO by highlighting science-based and data-driven approaches that help prevent foodborne diseases and strengthen the consumer protection. We will explore pasteurization as a cornerstone of milk safety, while also addressing other scientifically validated treatments that contribute to safe dairy consumption. By drawing on global evidence and practical examples, the discussion will examine how effective milk processing supports healthy diets, builds consumer confidence, and enhances resilient food systems across different contexts worldwide. The expectation is that this event will bring together professionals, researchers, and stakeholders from the dairy and food safety sectors to exchange knowledge and reinforce the importance of preventive measures in ensuring food safety for all. And in bullets, it's about food safety, uniform quality, food security, nutrition preservation, and international trade. Next slide, please. So go ahead, Francois.
I hope I can control. I give it a try. Doesn't seem so. Yes, I do. So welcome everyone. I'm going to start today on the theme of the World Food Safety Day with pasteurization as a right now very global food safety solution. It was implemented in the 19th century, but nowadays it's a heat treatment that you find very standardized and present in mostly in dairy. But it's not coming from dairy, as we will learn today. And you see also this, what we learned from the past and also what we might have forgotten when we implemented pasteurization. So pasteurization, when it comes to food safety management within the dairy chain, is really considered as a critical control step in order to ensure that we can lower the microbial burden inside the raw milk when it's intended for specific products. Does not mean that it's mandatory and must be eaten everywhere. There is still a very wide use of raw milk as a support and as a commodity for food production, but mostly for international trade, it's still pasteurization. And when you think with people who are not microbiologists who hear about pasteurization in the factory, they have the belief that pasteurization was implemented in order to control the burden of Listeria monocytogenes. Point is, Listeria monocytogenes was isolated for the first time in the late 1920s. It was only identified as a foodborne pathogen in the early 1980s. And the rule for in dairy came a little bit after. So definitely not pasteurization came in place almost 100 years before the identification of Listeria monocytogenes as a major concern from dairy. So we need to rewind back a bit in history. Yes. So heat treatment has changed on the food and the composition, microbiology, chemistry, and physics of the tissues. Heating a product is often used to make it better digestible, which is the case for meat and vegetables. Also less toxic. There are some vegetables that you will not heat raw and that you want to eat it, but also it's more durable. We've seen that when the product is heated appropriately, then it will reduce spoilage and safety because, and we know it since the mid of the 19th century, the spoilage microorganisms present on the food item has been destroyed. So fire, if we rewind very, very back, fire was domesticated many, many years ago in Pleistocene by Homo sapiens. And for many years, that was one of the major conservation of food was either heat treatment with a fire, with salting or fermentation. And in 1975, Napoleon Bonaparte, not going to go into politics on this one, but there was a huge expansion of the French Republic and then the French Empire. And he has this belief that an army travel on its stomach. So he proposed a price of 12,000 francs back then for anyone who could invent a method of preserving food. Because if you have spoiled foods and at some point the army is not moving anymore. So that's part of a presentation I made many years ago in Washington for the ICPMF predictive modeling conference, and it was taken on back in a food quality in 2010. When the major heat treatment that we have apart from pasteurization is apertisation, and apertisation comes from Nicolas Appert. And Nicolas Appert was a French scientist who shown that when you eat the process and you put it on glass jar, then you can keep it for many years. The process was implemented by another Frenchman, Pierre Durand, who immigrated to England and became known under the name of Peter Durand. And he was using containers out of tin plate instead of glass in order to have a better industrial process of eating the product. And the scientific assumption at that time was that food was preserved because of the absence of oxygen. Then comes another French guy and another Napoleon. So that was not Napoleon the First, but his nephew, Napoleon the Third, who asked Pasteur to work once he discovered the germ theory on the capacity of storage of wine for the French army. And again, I won't go into details what it means if military works on wine, but that's another point. So the first patent of heat treatment coming from Pasteur was on wine for the degradation of acetobacter. And these first experiments were made by Vernier de la Motte. And the other guy you see in black and white is Sir John Lister. And he was a surgeon who also worked on a germ theory and shown that if you clean your tools before making an operation, you will have a higher recovery of your patient. And Sir John Lister is the name used for Listeria monocytogenes. Then, with milk becoming a commodity for trade and the booming of the milk production, there comes also the point that if you want to have international trade and ensure that you don't have any spoilage from this commodity, eating is an interesting solution. And the idea came from a German chemist, Franz Ritter von Soxhlet, and it was widely applied, example given in Denmark for Danish butter to be sent internationally, because once you eat the process, you can delay thawing and avoid market loss. We know also that by that time that the major microbial concern for milk, for raw milk, was tuberculosis of bovine origin. And there was a lot of work done in the US for implementation at the wider scale of pasteurization in order to reduce the burden of tuberculosis induced by milk and other diseases for the generally healthy population. And as you see, initially there was many different type of treatment, and it was very empirical. And some were looking for 1 minute to 70 degrees, where the New World Board of Health was recommending 3 minutes. And right now we came to a more relevant pasteurization step of 72 degrees for 15 seconds. So this is a proposed time chart. The initial one was in 1912 by Bruun about bovine tuberculosis. And another bug came into being identified as a concern in raw milk. It was Coxiella burnetii, and that was in the early 50s, early 60s. And there was another heat treatment proposed that was slightly higher. So if you compare bovine tuberculosis at 145 Fahrenheit, that's 18 minutes, but for Coxiella burnetii to reach the 5-log reduction, that's 30 minutes. That was the organism of the Q fever. So pasteurization as a heat treatment change into process parameter based on the identification of the pathogens of concern that we do have. The approach was really killed by design. You find a bug and you decide that you want to reach the 5-log reduction using the Bigelow model. Right now, we know that there can be also better milk management at collection at the farm level in order to reduce the prevalence and as such reduce the heat treatment. I'm not going to go into details today on the technological backsides of pasteurization, but denaturation of proteins and fouling is one of the major issues that we have to deal with once we use pasteurization in the process. So pasteurization of milk, when it started to be implemented, as usual, like any new process, there was a huge pushback. And this time the pushback was mostly coming from the people who were supposed to put pasteurization in place within the industry. And it was challenged by milk producer as denaturating the milk matrix and the nutritional properties. And this is an interesting article in the context of today. It was written in 1924, so almost really 1 century ago, and it starts by human nature seems prone to forget and speak about the failure to vaccinate against smallpox. You replace smallpox by meal, and you are in the situations that we do have today. We often have the tendency to forget when something is in place, why it was put in place at first, what's the impact, and then you want to challenge if it's really necessary because the burden is forgotten. We do not remember anymore major outbreaks as there could be in the past with bovine tuberculosis in the consumption of milk. So then there is also this trend that you want to go as natural as possible. The point is that nature sometimes is not safe and you have to be careful. And interestingly, the initial argument used by milk producer to limit the implementation of pasteurization in the dairy chain are nowadays the one used for customers or associations that want to go to more naturality and get away from eating the products. If you want to have an idea on measurable positive impacts of pasteurization, there is this interesting document on the milk-borne disease in Massachusetts, surveillance from Bigelow and Forsbeck. And you see that in the early years, like 97, 1914, when per se we did not have pasteurization in place, the incidence of cases was quite high. So you had in these 7 years more than almost 10,000 cases and almost 100 outbreaks traced to milk, mostly typhoid fever, septic sore throat, scarlet fever, and a bit diphtheria. And slowly but surely, the number are decreasing, and they are decreasing because of the implementation of pasteurization. And the decrease is huge. Within less than 20 years, we switch from 8,000 reported cases to less than 200 reported cases, having also in mind that by that time there was a major boom in milk consumption. So the reduction of diseases thanks to pasteurization was tenfold for the outbreaks from 72 to 9, but almost 50 to 100 folds in terms of cases traced to milk. And we do not have the number of cases per milk consumption, but it was really a major improvement for milk hygiene and also help milk becoming a commodity to be consumed in a wider scale. And without pasteurization, we have to be aware that without pasteurization, milk would not have been the commodity that it is today. So as a French guy, I'm particularly not opposed to raw milk cheeses or raw milk. I'm myself a consumer of this type of products, but we have to have in mind that when it goes to industrial scale and international trade and reducing to an acceptable level of risk for sensitive consumer, the material burden, pasteurization was a huge step forward. And this pasteurization was recently, we had a publication from 10 years ago on the review on the processing advancement pasteurization and the link to cleaning and sanitation, because pasteurizers get fooled. So at some point, you need to clean these equipments and open them. And this is something that we do have with internal inspection. Now, by the times the first pasteurizer was put in place, it was with visual inspections. Now we've got endoscopic camera. Pasteurizer are also new designs for hygienic design, for better cleanability, and we also monitor very closely by calibrated measurement equipment, the temperature and the flow of the milk within the pipes in order to get the most standardized process as possible. And it's highly regulated either by the Pasteurized Milk Ordinance in the US or other documents. And in this publication from 2017, they push forward as next steps for understanding what could be the major technological issues that we will face in the coming years on pasteurization. So this was 10 years ago, but you see that they were pretty accurate. The first point is a process verification. So we have now a very standardized approach when it comes to the pasteurization value that you do want for your equipment. And it's a requirement either by the authorities or any food safety certification scheme to show that you have a validated process, that you are monitoring the limits and you verify regularly that it's working. Pasteurization, it's a heat step, which means it requires energy. So we are also considering the environmental footprint of pasteurizers, and the equipment that we do have nowadays are not so much energy consumers as they used to be in the past. And what becomes the challenge now is the reference to other food beverages. And I'm not going to use the terminology that they had in the publication, because per se there is no alternative to milk and there are other solutions, and it's important to know that what is valid for one food matrix is not for another, and it's important to regulate as much as possible. And in case of the usage of the heat treatment with pasteurizers as an equipment for a new food matrices, the values that were implemented and that are regulated for milk will be challenged, will most certainly be different, and it's important to revalidate the pasteurizers if you change the food matrix. So we will discuss today alternatives to pasteurization, but it's also important to have in mind that pasteurization is highly regulated in milk, and it's not the case in other food technologies. And with that, I'm concluding in the 25 minutes. I'm on time. Surprising. I'm quite surprised myself.
And those of us who know you, Francois, are a bit surprised too. But
Yes.
Thank you very much for taking us through the history of the early ages of heat treatment and conservation of foods until present stage. Yeah, I cannot see if there are any questions in the chat function. Maybe Aurélie, you can assist me.
I do not see anything in the chat yet.
Okay. Then I have a few questions that I'll raise now, and then we will leave room for all the questions in the end of the presentations. You did touch upon it, Francois, but is pasteurization still needed following the major improvement of hygiene at farm level today, especially in the past, I would say 15 to 30 years, we have seen quite a difference, quite an improvement at farm level.
Yeah, that's something which is very important. We cannot trust only one control measures to make all the jobs when it comes to food safety. And hygiene, good hygiene in the milk practice means also that the milk will have its intended nature. Because yes, pasteurization as a killing step can reduce the microbiological burden, but if the milk you receive is already spoiled on the technical perspective, either through a proteolytic or lipolytic activity, then you won't have in French, you say fromageabilité, you won't have a milk which is fit for purpose to do milk. It's also a specific topic we do have with UHT milk. We know that with UHT milk, if you have a initial burden of Pseudomonas aeruginosa, even through the heat treatment will kill all the spoilers, the enzymes present in the bugs will still be present and can link to enzymatic spoilage of the milk after the heat treatment. So pasteurization is not a magic wand. It does not make everything disappear. It's still important to have at the farm level good hygienic practices, and then on top of it, pasteurization is a major step for security. But if the milk is spoiled, it won't save it. It won't save the food matrix.
Thank you. Actually, that's a message I always pass to farmers and those who supply the whole chain between farmers until the dairy, that you can make excellent. You cannot make excellent cheese out of spoiled milk, but it is quite easy for a dairy person in the dairy plant to spoil the milk, even though the quality of the milk was excellent from the beginning. So we need to ensure that the quality from farm level is the best as possible, and then in the dairy plant you can build upon that quality. So thanks a lot. I think we'll move on to Marie-Claude now, and then we'll continue with all the questions after that presentation too. So please, Marie-Claude.
Thank you. So I will just look if I am able to change the slide by myself. Yes. Okay, there we go. So thank you for the kind introduction, Christian. Thank you also to the International Dairy Federation for the invitation to celebrate the World Food Safety Day with a focus on pasteurization. And I would like also to thank you to the online public to be with us to celebrate that important day. So, let me go back to my second slide. There we go. So this is a screenshot of the World WHO website. And when I stood out to me, I underlined the sentence in blue that yes, foodborne diseases still remain a major global burdens. And I think it's a good reminder to us that, like Francois mentioned, that raw milk can be unsafe, and then that no one should get sick also, and that the importance of the science. And really those keywords, unsafe, no one, and science, drive the presentation that I will do today. So we will do a brief history. So thank you, Francois, to setting the stage with all the information. We will go also through the validation. What are the tools to make sure then the pasteurization is done properly? And then we will see or look into a glimpse of the future on looking, or is there any alternative that can be done to replace pasteurization, and also what is the state of the science. So we will move. Sorry. Okay, there we go. So I would like you to imagine yourself in the industrial revolutions, where you have to leave your agricultural life to go to a city where the apartments are teeny. There's a crowdy people. You now need to pay for your food. So women, children needs to go to work also to pay for renting the house and also the food. So there was also a decline in breastfeeding in that time. So what we know also is that the sanitary condition was not as today. The milk quality was also poor because it was the emerging of also dairy factory production, where there was not a lot of food for the cow, and a lot of producers were feeding the cow with the leftover of brewery and distillery company, and there was a clear increase in infant mortality also at that time. So I'm going to go very quick because François already talked about the germ theory. It was at that time also that there was the first link between the raw milk contamination and also the typhoid fever. It was the first thing in 1870. And since that, the microbiology field improved. And as we know now that the milk can contain harmful bacteria like Listeria monocytogenes, like François just discussed nowadays. But before it was more about Coxiella burnetii and Mycobacterium tuberculosis. And clearly, the science showed that when you pasteurize milk, there is a clear decrease in infant mortality. So this life-changing technology was intended to reduce a 5-log reduction of the most resistant non-spore-forming bacteria, which was at that time Coxiella burnetii and Mycobacterium tuberculosis. So the pasteurization, the full implementation was more like a bumpy road, if I can say it like that. It took nearly 15 years to get the full implementation. When the first adaptation of the pasteurization process for milk was done in 1870, and then 12 years later there was the first processing equipment that was available. And then after that, Mr. Success invented a way to sterilize the milk in the bottle directly. And it is only in North America, at least, that in the early 19th, it was the mandatory pasteurization, and it was starting with batch pasteurization. And at that time, there was problem with time temperature control. There was a lot of contamination because the milk hygiene was not as today. So contamination of the raw material and post contamination, and the science and the technology continue to evaluate. And now the gold standard is the high temperature short time pasteurizer. So like as mentioned, it was a bumpy road, and we needed to have indicator to make sure make sure that the pasteurization was properly done. So the first indicator that is used by the industry is the alkaline phosphatase, which is an enzyme that are naturally present in raw milk. And it happened that the inactivation kinetic of this enzyme is similar to Mycobacterium tuberculosis. And here I show you an example of a colorimetric method that can be used to look if we have a faulty pasteurization process. If the colors stay yellow, it means that the enzyme is still active. So the pasteurization was not done as properly. At the right side of the slide, there is another method that is used, which is the controlling the time and temperature to make sure that we have obtained the proper one. So at the right side of the slide, you can see a flow chart of a high temperature short time pasteurizer. And then I circle in green the controller, the temperature and time controller. And there's also a safety device that we call the diversion flow device if the temperature or the time is not properly done. So the milk will follow the red line and go back to the balance tank to be reprocessed. There's other method that can be used for verifying pasteurization. So for example, if we control the time temperature, we ensure that we achieve the pasteurization, but it doesn't give you an insight if there was any post-contamination, for example, if we have a biofilm formation, a crack or leaking plates. So for doing that, bacterial hygiene monitoring can be a good way to validate post-contamination, and the Enterobacteriaceae monitoring can be a good indicator. There's also other indicator that are available, like for example, the lactoperoxidase, which is a antimicrobial protein that is naturally present in milk and is sensitive to heat treatment. There's also other indicator like Maillard reaction products, for example, the furosin or the 5-hydroxyl furfuryl, and also the degradation of lactose with lactulose. But again, those two lactulose and Maillard reaction product is not convenient if you do only a pasteurization, but is rather associated with sterilization. There's other indicator or alternative testing to validate the pasteurization, and the EFSA released a complete review on that in 2021, and you have the link below if you would like to have more information about that. So for the legal definition of the pasteurization, in Europe and in Canada, it's clearly stated that you have to have a negative results of the alkaline phosphatase activity. So it means then even in the definition, you have to make sure then you can prove that the pasteurization work. So with all of the information, so we know that the pasteurization is still a life-saving technology. So why we wanted to change something that it works? So I think it's a valuable question, and the context for sure has changed. We have now other issue like the climate change and all the resource-intensive process or challenges. Also, consumer wants to have naturality of the product. And also in the dairy processing, I'm sorry, I struggle with the changing of the slide. There we go. Okay. So also the dairy processing has evolved. At the left side of the slide, you can see then all of the rectangle are product or co-product that can be extracted, concentrate, or dried from one raw milk. So it means then it evolved a lot since the beginning of the pasteurization. And the heat treatment in the dairy industry, yes, it's still a matter of safety, but there's also a quality-related processing that we can do with heat treatment. So for sure, the legal pasteurization of the sterilization of the milk still rely important for safety-related purposes. But if we want to make yogurt, for example, we need to do a more extensive heat treatment to make sure that the whey protein is denatured to have a proper gel formation. And also, if we want to do, for example, raw aged cheddar cheese, you might want to do thermization, which is basically a sub-pasteurization to reduce psychotrophic bacteria spoilage before to making your cheese. So I think it's valuable to ask how or why the industry wants to innovate. So this is the top 3 I extract from 3 different survey that was done all around the world. And it happened then the quality of the product, or improving the shelf life and reducing the product costs are the main motivator for the food industry to look for alternative. And this is not specific to pasteurization, but in food processing in general. And our team also explore if alternative to traditional technology in the food processing landscape in general, what was the key driver. So we have had 131 participants across all Canada that they were involved directly in the R&D or innovation process within their company. And it happened that clearly to look for replacing traditional technologies, it needs to have a clear economical benefits. The product quality must be improved, and also some companies are looking for expanding and looking for new market. This is also a key driver for looking for an alternative technologies. And we push a little bit further and we ask to the respondent which emerging technologies need more scientific evidence for you to build a business case and to do a proper assessment for your company. And it appeared then the cold plasma, pulse electric field, electrolyzed water, supercritical fluid and extraction, and ultrasound were the top 5 technologies. And we push a little bit further to ask what is limiting you to adopt those technologies. And clearly, without no surprise, the cost of building the new process or buying this equipment, doing also the R&D work was limiting, and also financial support. Often the price increase with new technologies, and also difficulties in validation. And today, with the time that we have together, I will only focus on one alternative technology, which is pulse electric fields, and also focusing on validation difficulties. What I mean by validation difficulties, it refers to the challenge that we have to prove that the technology it works as intended, that it can have, for example, the same microbiological load reduction as we wanted to expect for pasteurization, for example. Also, can we use the same quality indicator to make sure that the process are working as intended as well. So the quality of the data is really important. How the experimental plan or the challenging tests is built is really important. We need to have sufficient data also in quantity to make sure then the risk assessment can be done properly, and a diversity of the data. What I mean by that is a representativeness of the data, which means to avoid bias, to make sure that we capture variability and also real life situation. And with that, okay. When we talk about pulse electric field, one of the main difference is that it is not the inactivation of bacteria with the heat, but with the electric field. So this is one of the main difference. You have here an example, a schematic example of the damage of the cell. So you have at the left side of the slide bacteria without the application, and then after you can see then when you have the electric current that pass through the fluid or the food, it will induce what we call the electroporation. So it will increase the permeability of the membrane, and above a certain threshold, the bacteria will be damaged and will be inactivated. And if we do process that are below that threshold, then the bacteria can recover. So this is really important to keep in mind as compared to inactivation by heat. So in my team, we undertake a research to look if the pulse electric field can be an alternative to pasteurization and thermization prior long maturation cheddar cheese. So what we did, so we received raw milk that was pooled, and then we did a microfiltration process to reduce the original microbiological load. And then we have done two different pulse electric field process with a pilot unit at 10 kilovolt per centimeter and 15 kilovolt per centimeter. And we spike also our raw milk that was previously microfiltrate with Lactiplanti Bacillus plantarum as a surrogate to Listeria monocytogenes, because we were not allowed to use pathogen in a biosafety level pilot plant. And what we get as a result in the percentage efficiency of the reduction of this lactobacilli, what we can see clearly at the right side of the slide is that the pulse electric fields treatment was not efficient as pasteurization and thermization to reduce this lactobacilli. And this result was also obtained by others in the literature, where when you use pulse electric field without heat, we have a minimal reduction of the microbiological load. But when you add another hurdle, the temperature one, so when you increase the temperature higher than 50 degrees Celsius, and then you combine with pulse electric fields, you can have a reduction of the microbiological load that is more similar to what we can expect with pasteurization. And also it is important to, when we compare as alternative to pasteurization, to consider the factor that it can impact the alternative technology. For example, for the pulse electric field, the operating parameter is really important. And also the matrix effect also, the fat and the protein content can affect the efficiency of pulse electric fields. So it means then if you have like a concentrate, a milk protein concentrate, you cannot use the same operating parameter than if you have a lower protein content. It appear also if the microorganisms that you are targeting are clumping together, have that tendency, it will decrease also the efficiency of the pulse electric field. So really those considerations need to be validated to make sure then the alternative process can be safe. Another important validation is to make sure then we can, or we can ask, can we use the current tools that are available, for example, the alkaline phosphatase test, to look if the process was properly done. Here you have an example of 3 different alternative methods. So the high pressure processing, pulse electric field combined with heat treatment, and also ultraviolet radiation combined with heat treatment. And in the column of the middle of the table, we can see then similar result to pasteurization can be achieved with high pressure processing, and also when you combine pulse electric field and heat treatment. But it is not the case with ultraviolet radiation. So this is really important to gather information into that and look for the for alternative. For example, if you want to look more deeper into the difference or the alternative technology with which combine heat treatment and ultraviolet radiation treatment. So we're now at the end of the presentation. So like I mentioned, the implementation of the pasteurization was a bumpy road. It took like nearly 15 years to be fully implemented. So for sure that the alternative will take also time, and it's really important to continue the research in that sense to make sure then we can gather sufficient data, relevant data to make sure then those alternatives are safe solutions. And just before I end my presentation, I would like to give you a sneak peek of an ongoing work that we have in our Standing Committee of Dairy Science and Processing Technology. So we have an action team on sustainable food processing that will look into alternative to pasteurization. And this work is led by Christian and Johannes. And stay tuned because there will be more knowledge that will be shared within these action teams. So I thank you very much for your attention. And if you have any question, I have already some question popping up in the chat. So thank you very much, and I will be happy to discuss with you about that. Thank you.
Thank you very much, Marie-Claude, for your presentation. I have a question right away, as I cannot see the questions so far. Someone will fix that, I guess.
Okay.
But one question is really about this, that you, well, actually both of you have been speaking about that the dairy business is conservative. It has taken 50 years to implement from the very beginning and to recognize pasteurization as a food safety technology. I assume it won't take 50 years to implement something else, but I do see for international trade that it is still pasteurization, HTST, standalone or in combination with alkaline phosphatase negative tests that will determine if you're permitted to do export to an importing country. Do we have what is the most obvious alternative at the moment to pasteurization as you see it? Any new technology that is right at the next step that you believe would be our next solution?
Do you want me to start?
Yeah, please.
Yeah. So thank you for the question. It is an important one, especially with all the globalization and the milk travel all around the world. From now, I don't think there's a ready solution. One milestone that I think is a drawback is really related to the legal definition of pasteurization, which is it's written that it needs to be a time temperature, and also we need to have a negative results of the alkaline phosphatase, at least in Canada and in Europe. So I think this is one of the limiting factors that hindering to have a ready solution. And also I think then it's important to continue, like I said, the research to make sure then there is a safe alternative and that we have validation tools also to ensure that it can be a safe alternative.
Thank you. And Francois, you also, of course, also spoke about the raw milk cheeses. And yes, it is possible to do international trade of raw milk cheeses. It's possible to do international trade of cheeses made of thermized milk. Then you just need to add some extra criteria. But as we today focus on the heat treatment and the pasteurization, do you see any obvious alternatives?
There are many alternatives. The point is there is a codex document that explains how you can use alternatives and how to validate, and the use lies within what we call surrogate microorganisms. And we had many discussions, for example, with HPP, high pressure processing, which is something that you find at one common process that does not impact per se the should not impact at least the matrix versus the heat treatment, because there's only high pressure. But we see that species are reacting very differently, and that you find that the efficacy on pasteurization on Lister and Salmonella can be very different on HPP with the food matrix. So the point really lies within the validation of the control step. There we have the issue. Either you use inside the factory direct trial with the pathogen of concern, but until now, I never found any factories willing to let Listeria or Salmonella willingly enter into the process. So it's about having pilot plan, then can do it. Or it's working, and there are many companies, and for example, the iFish in the United States or Novolis in France is working on this, on promoting the use of surrogates microorganisms, where they show on the pilot plan that there is equivalence of behavior between these surrogates and the pathogen of concern you're looking for, and then you can use your surrogates inside your setting. And it really lies to what was mentioned in the review in the journal Dairy Science, like after 100 years of pasteurization, it's still about process verification, because even so, you say that 72 degrees, 15 seconds, and in that case for the equipment, you need to prove that you have the 72 degrees and that you have the 15 seconds. So we still spend a lot of time within the facilities on process validation for this type of control measures, and all the knowledge and the know-how we get from this validation can be used for alternative techniques. Point now is that some alternative techniques have been quite disappointing. So we do not reach the same efficacy for now as we do have with pasteurization. So it's a bit difficult to get away. That's what we mentioned, the safe harbor. You'll find there, it's a nice place. It's maybe not the best, but it works pretty well, and we know it. So there is a bit of reluctance to change.
Thanks a lot, Francois. So, as I unfortunately cannot see the chat, I will need to ask either the EDA Secretariat, or I heard that you, Marie-Claude, could see the chat.
Yes, I can.
Okay,
I can.
great.
So, Francois would like to continue because you have a question for you. So, what are the disadvantage, harmful effect of pasteurization?
Yes. Disadvantage of pasteurization. First is that as any equipment, you need to show that it's working. So it requires some documentation working. Second thing is when you eat the milk, I mean, you can do it at home. When you eat the milk, there is some modification on the food matrix. And this is something we do have a lot right now. I am in the infant formula factories, and we are discussing about fooling of the evaporators and atomizers. When you eat, the proteins coagulate, fools, and get inside the tube. So you have a maximal time of use, and then you need to stop and clean all the equipment before you restart again. Because we discussed today about the positive impacts on getting rid of pathogen of concern. Now the point is, on a microbial perspective, a pasteurizer or an atomizer for drying infant formula, which is not under control with fooling, will lead to highly resistant spores with thermophilic microorganisms. So that's why Pasteur always used to say the microbes will have the last word. When you kill some of them with pasteurization, you create something that is fit for purpose for others. And we have this issue with Bacillus thermophilus, for example, in UHT milk. So, and you have the nutritious impact that needs to be evaluated. At first, because the initial step of pasteurization were too high, there was what we call this Maillard reaction, and then the taste was not satisfying. Now, let's be honest, between raw milk or well masterized UHT milk, there is no so much difference. It's all about the standardization. It's not per se the heat treatment that you might feel. If you feel a burnt in the sensorial testing, there is an issue with the equipment. But it's really that whenever you eat, has an impact also on the composition, and it needs to be considered.
And if I may add,
Yeah.
that, well, of course, the focus today is on food safety, but also quality, especially for long ripened cheeses. You can see that if you normally make a cheese of raw milk or of thermized milk, and you want to do the same cheese out of pasteurized milk, there is a risk that if you do not adapt, that over time, when breaking down the proteins during ripening, there will often be seen some water flowing from the cheese. So for export purpose, it's actually for certain cheeses preferable to not pasteurize for the quality purpose, at least.
Yes, this is a good point. For sure, we know then the contribution of the indigenous microbiota play a role, especially for long hold cheese, cheddar cheese, for example. So for sure, when you pasteurize, you reduce, yes, the pathogens, but also those beneficial lactobacilli, for example, that you want to have. There's alternative to increase, or in North America to accelerate the ripening of pasteurized cheese, but for sure it's not as when you have the raw pasteurized, but there's alternative to palliate and to help during the ripening process also.
Well, you better continue with the questions from the audience.
Yes. There's a question from Catherine. She wants to know which alternative method is the most smoothest one when looking at nutrients like vitamins. So I will speak more about pulse electric field because it's more in my expertise. So for sure, it's a non-thermal technology, especially when you don't use heat. So for sure, it can help to keep the nutrient like the heat sensitive one for sure. But as mentioned it in my presentation, the drawback of that is that we don't have the reduction of the microbiological load that we expect if we compare to pasteurization. So I think there's a fine balance that need to be fine also when you are looking for alternative to pasteurization to achieve the reduction load that is expected, and also to have a minimal effect on the nutrients, the heat sensitive nutrients in milk.
If I may add on that, I saw a pilot plant using magnetism to heat the milk. And you can say, yes, it saves energy, probably, mainly because you will then heat the milk even faster, meaning in a shorter step than if you heat treat using a pasteurizer. Then I guess you would probably have to take into account that as the curve will be steeper when heating the milk, you might need to keep it for a bit longer time than just the 15 seconds to achieve the same effect. And by that, I'm trying to say that every time you use another technology than the one being validated, you always need to take into account, do you achieve the same reduction as is accepted for pasteurization today?
Yes, exactly. So really, the standard of validation is really important. So, François, you talk about the challenge tests and the bacteria to target, but also it's important to consider the validation tool that is existing, or if we need to look for alternative that will prove that the process is done properly.
Yeah.
Yeah.
And it reflects to the questions of Catherine Lehmann about alternative methods for the smoothest for looking at nutrition like vitamins. We have this focus because of the history with on microorganisms, but when it comes to food safety, and particularly in infant food, nutrition is a key component. So anytime you have a new process, it's also important to know what can be the impact on the composition and nutritional aspect. We did not speak, but for example, there is a huge consumer mistrust of irradiation in Europe, and which is a process that can be used for debacterizing, but it also creates neo-compounds on a food matrix, which needs to be assessed whether it's safe or not. And also the impact on the nutritional aspect is very important, because yes, it's about having safe food, but also safe and nutritious food. Because if the food is not nutritious, say you lose all the benefits and the expectation you have from the dairy products. That's why it's not that easy to move from this safe harbor, which is pasteurizations, to a new process, regardless that the fact pasteurization is not perfect. But at least we know it works, we know the implications, and there are many factors, some we might not be aware of, to consider when you move from one process to another. So it's we always a big push from innovators to go for these new solutions, but to have to be careful, because they only consider a part of the picture, which is mostly for the safety one, and all the nutritional quality aspect, which are our competitive advantage as food business operators. We do not communicate so much, and this is where we do all the testing and we say, yeah, for what you say it's working, but there are other effects we are not very satisfied with. Change of colors, for example, can be important in change of the product. You have the impact on the fat matter. Oxidation of the fat matter can be an issue. So it's far more complex than just the bacteriology when it comes to changing one control measures by another.
Good. Do we have more questions in the chat?
No, not yet.
We exhausted the audience.
Yeah. But then I do have, what was it? Another question, note it down. Francois, you spoke about the resistance, you can say, in the beginning of the use of pasteurization also. And what were the first technological hurdles to the implementation of pasteurization? And are they still valid nowadays?
The first hurdles to implementation of pasteurization was technological hurdle, with ensuring consistent process and not overeating. So I must say right now, and I hope Marie-Claude, you will agree with me on that, because Marie-Claude has all the processing and science more than I have. But we can say that we have now very relevant equipment and very reliable equipment that we did not have in the past. And this is also why people were not so eager to use these new tools, that they were, let's say, not very providing a lot of trust when you saw where the first equipment went. But now the technology is really efficient, very as much improved, luckily in 1,000 years. So right now there is no real technological hurdles to implementation of pasteurization as a process step.
Okay, and of course we do need to take into account the very diverse situation that dairy producers around the world is in. And I totally agree about in the developed areas where we are really having the state-of-the-art equipment. Of course, there shouldn't be any hurdles or problems. Whereas you can say in less developed areas where they probably do a lot of batch pasteurization still, as it is the only possibility. I assume that we still do see, you can say, what do I say? Well, that the milk quality, that the nutrition of the milk is affected by the heat treatment.
There is overeating. There is for sure in some countries overeating, and even for very industrial process like UHT, we have a lot of sensorial testing in order to make sure that during the process, I mean, you have to imagine millions of bottles going in there. We did not have any overeating because at the end of the day, it's about a nutritious product that you want to market.
Yeah. Exactly. And what we also need to take into account is the quality, the stability of protein, as that can be quite unstable during heating, especially UST. And that's also the reason why certain stabilizers are permitted during this treatment. Yeah. Thanks a lot. Yeah. I was wondering, Marie-Claude, about do you see any obvious types of partnerships or collaboration that should be considered to accelerate the industrial adoption of emerging technology in the dairy sector? Maybe AI or some scientific bodies, including IDF, of course, that could play a larger or major role.
Thank you for the question. Yes, for sure. When you want to look for alternative to pasteurization, for example, it can be a long journey, and partnership can be a solution to accelerate the validation process. So in our survey, we asked the question. For sure, it was not specific to dairy, but I think it applies also to the dairy sector also. So the first one was supplier of the equipment. So this can be a good way to look with the supplier. Research institute like governmental or university because those institutions may have the equipment and are able to test in a pilot plant condition, for example, or in lab tests. Also commercial laboratories and R&D private institute can be also partners. So really what we need here is to gather some data, relevant data to look for the validation process. And yeah, you touched base a little bit about the artificial intelligence. I think in the near future, it can be a help. I'm not an expert in that, but for sure with all of the data logger that we have equipping the equipment, all the Internet of Things that gather a lot of information, I'm sure then AI tool can be part of the solution, especially if we know more how, because we talk a lot about the black box. So we know we enter the data and we have an answer, but we don't know exactly what is the mechanism behind the data integration. So for sure, if we know more about what's getting inside that black box, it will help to have a better confidence on the results that was out of this modelization, for example.
Okay, thank you. And then, well, to both of you, but probably especially to Francois, there was this resistance about the pasteurization in the beginning, but we also see some resistance against that technology today, even though it is proven to be very efficient. But do you see any reason or understanding of why do we see this resistance from consumers? Is it simply a lack of understanding the risk that they might have, or yeah?
It's more that they're not aware of the risks they might want, they are going to take. It's that there is a quest for naturality and going as close to nature as possible, forgetting that by design nature is treacherous and will get the best out of us. So you can go for raw milk. That's fine. I mean, I'm French. We have a lot of raw milk products. We're using a lot. But in order to make raw milk and raw milk products, we have specific control measures in place. And we've seen in the US, for example, a trend to go for consumption of raw milk directly at the farm level that were not authorized to deal raw milk, and they were dealing raw milk for pet, and in fact selling this to consumer directly, and then it led to outbreaks of Campylobacteriosis and Listeriosis outbreaks. So if you want to get away from pasteurization, that's fine. Then you need to make sure that all the barrier that you lose with this step must be put somewhere, and then it must be put upstream in the milk production. So when you visit farms and facilities and milking devices, you really see where if you have in a pasteurized zone or in a raw milk zone. And making raw milk can be done safely, but it's more expensive because it requires more man time, more cleaning of the animal before the harvest. It's a specific robot design. And sometimes people just forget it. They say, okay, I don't have any issue with pasteurizer. With a pasteurizer, let's put it out. Yeah, but if you put it out, then everything can goes in. So it's really some naivety from people with no knowledge, but really with this quest for naturality, that they forgot that everything is possible if you put the means in place. If you don't put the means in place, then you expose yourself to danger while thinking that it will be safe by design. Nothing is safe by design. It needs specific control measures in place. If you put one out, you need to put others upstream before.
Exactly. One, you can say, a little bit entertaining example in Denmark is that it is permitted for certain restaurants to buy raw milk at farm level, but then they need to heat treat the milk themselves in the restaurant. And what happens is actually that, well, if in a restaurant you need to heat treat your milk, it will mean that the heat treatment will be more severe, because during the time that you heat treat your bags of milk to 72 degrees, that will take longer time than in a pasteurizer. But that's about storytelling, that the restaurant can tell to the consumer, to the customer, that they use raw milk collected at farm level. So it's also about consumers being fooled, really. Yeah. So any new questions coming up in the chat?
No, not
No?
yet.
Okay. Because then, not really concluding as such, but as I hear your presentations, both of you, it's really about we have trust in the technology used today. The pasteurization, you do not necessarily have to pasteurize milk because you can produce safe dairy foods without heat treatment. But then you need to take extra precautionary measures and to be more observant, more keen to document what you're doing. But when you heat treat, it's really difficult to develop and to validate, which is the key word here, to validate that a new technology is as efficient, as safe as pasteurization has been for so many years now. And being in a conservative business like the dairy business and doing trade across borders, so far we do not see real alternatives to heat treatment. Yeah, so I don't know if you've got some final comments from your side on this very important issue and the way we're dealing with it.
Yeah, maybe I can jump into a final comment. Thank you for the summary of our discussion today. I think then one key solution, if we really want to if it's needed to have an alternative solution to pasteurization, I think then key solution can be to make sure that we are able to map or benchmark the technology with the relevant standards. So we talk about validation is really important, and really identify early issues, for example, when we did our experiment with pulse electric field, we realized that there was no safety as in the HTST. So you pass your product and then you end up with it's a continuous flow, and then you end up with a product. So if we had a contamination in between, there is no safety on that. So we needed to find solution with the supplier. So I think if we can early on detect that, I think this can help to look for alternative. Establishing also validation environment for testing with the scientists, researcher, the industry. I think to have a stakeholder and doing that in a pre-competitive way, this can help also to look for alternative for heat sensitive product. For example, if we look at lactoferrin product, which is in the rise, and also promoting, really the collaboration, because this journey, I don't think it can be doing alone, especially if we need to change regulation. So really, it would take a stakeholder to make sure then alternatives are safe.
Thank you.
I turn over to François.
Please.
No, I fully agree with your conclusion, Marie-Claude. That's exactly we have a project, a European project going called Catalyze, about bringing together all stakeholders, and stakeholder means regulators, innovators, and industry, because the innovators it's very complicated for them, because they need to convince the industry. Industry is relevant because it doesn't want to move, its regulator doesn't say yes, and so at some point we need to come in this gray zone where we accept that some innovation will need specific surveillance from the authorities to be validated. And that's for me the point where we can move forward, is we put out all the orders to innovation, and one of the orders of innovation is really that you need to have regulatory compliance. And when it comes to food safety, the basic is regulatory compliance. A new technology which is not understood by the people in the field will not be known and understood by regulators. So it takes more time than the valley of death that the startup wants to survive. So we need to come with a new scheme where I'm not saying for fast track approval, because that would be putting the consumer in danger, and we don't want that. But at least a more direct communication directly with regulators when we are working on implementing something new, so that they are aware of what we are doing, they are coming with us. And once we are ready for full-scale implementation, the regulatory hurdle is over, and we get the approval from the authority. So it's really about collaboration and putting authorities in the field.
Yes, thank you very much. Building upon that, one of the projects within IDF these days, it was mentioned in the beginning, is this action team trying to really interpret, to understand the criteria for mitigation of foot and mouth disease in milk. And there, pasteurization is really key, but understanding about the criteria, even though we've understood pasteurization for many years now, even understanding these relatively simple, clear criteria is difficult, because they can be read differently, understood differently, depending on whether you are exporting or importing, really depending on what is your intention of reading this text. So even though we've got a well-known, almost old-fashioned technology used every day in the dairy business worldwide, it is still a technology that we need to investigate, to maintain, and at the same time looking into new alternative methods to develop our products, our raw materials, to really ensure that the nutritious parts of milk will be kept also all the way to the consumer. So please, François.
Yeah, we have one question in the chat from Françoise Lerich about phage-based controls of pathogens.
Oh.
That's not the easiest questions to get before the end, Françoise. Thank you for this. This is really a phage-based control is really a good example about consumer awareness, because how do we explain to the consumer that we have put viruses deliberately in the food, because phages are a virus? That's the first thing. Second is getting understanding from authorities that it should be approved. Right now, whether it's phage-based or bioprotection with using specific starters, it's considered to be efficient in a certain way, but not considered as a critical control measures with a huge reduction step comparable to these traditional measures such as heat treatment. The IDF is working for many years now, following discussion we had with the WHO on promoting bioprotection with food cultures. And this comes from an initial workshop in 1995. So it's starting to date a little bit from the WHO on this. But we understand that, and it's supportive, it's helping, but it's not a game changer. And really, I'm not a big fan of these marketing terms, but let's face it, pasteurization was a game changer from the industry. And right now, we don't have a game changer coming such as pasteurization. So whatever we will do as alternative to pasteurization won't have the same impact, and we need to deal with it. And then we need to switch from an approach where we had one step that does all the job to several steps that do the job. And then it requires more know-how, more knowledge on the process. And this is why among these technologies, phage-based controls has been discussed for more than 20 years now. I remember my first discussion with Alex Bongrand on this topic, but still not implemented at full scale because it's not a game changer, and it's working, it's efficient, it's helping, but that's not how you win the race.
Thank you very much, François. Any new questions in the chat? Otherwise, I think we'll
No,
conclude.
but we got a
No.
badge from the chair of the SPCC. Thank you, Richard.
Thank you, Richard.
Thank you. But then I believe that we fulfilled our task, especially you, Marie-Claude and François. With that, I believe we will close the meeting. Thank you very much for all of you attending. And of course, those of you being a member or active within IDF, please continue the discussion, the dialogue in the relevant standing committees. I will reach out to the three of us or the Secretariat. So have a nice day, good evening, good morning, wherever you are. Thank you.